For over 100 years, model trains have been enjoyed by many, both young and old. But what could model trains have to do with math? You'll soon see as we explore angles of elevation and depression. First, let's think about the meaning of line of sight. Line of sight is the imaginary line along which an observer looks. In this illustration, the person is looking down at the flower. You could also be looking up at a bird. When you're looking up, for example at something that is elevated off of the ground, your line of sight is creating an angle of elevation. The horizon is formed by a horizontal line at eye level. Walking uphill and taking off in a plane are also examples of angles of elevation. In contrast, looking down creates an angle of depression. Again, the horizontal line is placed at eye level. Anything below eye level is at an angle of depression. Skiing downhill is another example of this type of angle. In this example, Abby and Becca are looking at each other. Abby's angle is an angle of elevation, while Becca's is one of depression. What do you notice about the two angles? Take a minute and think about it. The two horizontal lines form parallel lines. These parallel lines are being cut by a transversal, and, as we all know, when two parallel lines are cut by a transversal, alternate interior angles are, that's right, congruent. So if angle A is 40, then angle B also has a measure of 40. You can use your trig ratios to calculate missing lengths and angles. Michael is about to shoot the ball from the free throw line. When he looks up at the basket, how far away from him is it? We can create a right triangle to find out. If Michael is standing 15 feet away from the basket and he is looking at an angle of elevation of 20 degrees, we know the side adjacent to the angle and we want to know the hypotenuse. What trig function gives us this ratio? And the winner is cosine. Cosine of 20 is 15 divided by the hypotenuse. So the basket is almost 16 feet away from Michael. Well, 15 feet 11.5 inches to be exact. Now let's go back to our example of the model train. I'd promised we'd see how model trains relate to math. As a matter of fact, designing a model train layout takes a number of calculations, but we'll look at only one. Like real trains, model trains can't climb up hills that are too steep. This is called the grade of the slope. For example, here in my father's layout, the uphill climb is an angle of elevation. My dad wanted to have the train climb 7 3/4 of an inch at a 5-degree angle. In order to determine how much track he needed to lay, he could use the trig ratios. Since we know the angle and the side opposite, we use the sine function to determine the length of the hypotenuse. Remember that sine is opposite over hypotenuse, so the sine of 5 degrees equals 7 75/100 over x. We'll need to divide since our unknown is in the denominator. Try it out and see what you get. When we take 7 75/100 and divide by sine of 5, we get 89 inches. The train needs 89 inches of track to make the climb. If the track is too short, the grade will be too steep and the engine may not have the power to pull the train up the hill. The angle of depression occurs when the train heads downhill. Less power is needed for a downhill route, so the angle can be different. Do you think the angle will need to be more or less? As a matter of fact, a larger angle works. This time, the train will travel down the 7 3/4 of an inch at a 6-degree angle. Notice the horizontal line is on top this time because it is an angle of depression. How long does the track need to be for this downhill stretch? Pause the video and try it on your own first. Did you get about 74 inches? Again, we will take the sine of 6 and make it equal 7 75/100 over x. 7 75/100 divided by the sine of 6 is about 74. My dad needed to lay about 74 inches of track. This will allow the train to smoothly travel down the slope. Model train builders aren't the only ones to use the trig ratios along with angles of elevation and depression, but they certainly have fun using math, and we get to enjoy the results.